system approaching perfection.
We'll walk deeper into the belly of the beast if it means I'm able to further...
All right, guys, it's Danny. I'm here with the Crypto Show, and we're back. We're talking with Colin from Nexus. We just did an interview with him the other day on the Crypto Show on live radio, but that was kind of dumbed down we had a Republican audience. Nah, I'm just kidding. But anyway, I want to dive a little deeper into what some of his technology is really about. And all the rage these days is Ethereum, EOS, and all these other different things that are creating smart contracts. And what is this, like world computer? What's it called now?
They call it that, yeah.
Okay, the world computer, Ethereum. And Ethereum is just this big ball of code that's kind of not modular, is the way you were explaining that to me. So your new white paper is Tritium, and it's a new solution for Ethereum, much like EOS has done. And EOS has tackled some of the problems, but you think that you can go a little bit farther with Tritium and solve even more problems. And so explain how modular is better than this glom of code.
I guess I can use the analogy of some of the early days of Cisco. So what they did is they were always rushing to market. They were trying to get their technology built faster than the competition. And so they didn't really put much design time into the code. They just built it to work. And what happens is, I use the analogy of it being like a big blob of bubble gum. If you try to pull one piece of code out, you get all these strings attached and then you break things. So the point of modular programming is that it's like a series of blocks where you can pull one block out and put a new block in. And so it allows it to interchange and be kind of like Legos or whatever you want to call it, so that it's easy for different components to exist within one another but be changed out in case one may not work fully. And so what we've done with Tritium is we've broken out the stack, right? Because as we know, the internet, it's built on the OSI reference model, which you have the layer 1, which is your physical, and your layer 2, which is your Ethernet, and then your layer 3, which is IP, and then layer 4, which is transport, and then layer 5, which is session, and then layer 6, which is data representation, and then layer 7, where the applications mostly operate, right? So the internet and blockchain, I've heard a lot of analogies used with them being very similar to one another. In a way, blockchain takes the internet to the next level. So with that analogy being said, you have the OSI reference stack, which operates mostly on layer 1 of our actual stack, and then we build on top of that reference stack so that you have layers of abstraction from the lowest levels. And then what that allows you to do is it allows you to have the proper developers and the proper levels to make sure that the integrity of each level is designed. You can't get a web developer to go build a new IP protocol. They're just not going to be capable because they're working up in layer 7. So that's what we've kind of done, and I think a lot of smart contracts are going to operate on layer 6 and layer 7 of Nexus, or the Tritium stack, which, to repeat it, goes network, ledger, register, operation, API, logical, and interface.
Okay. Now, real quick before I get too far ahead, I was a little rude. I didn't introduce Juan Galt over here. So Juan is far more technical than I am, and he'll be able to kind of interpret some of these things because I really don't understand a lot of this. And let's go back. Nexus is the coin this is all built on. So this is another blockchain coin like Bitcoin and Dash and all these others, and you have some innovative tech that makes it very much different than these other coins, and we'll talk about that a little bit later. But back to Tritium, how will I be able to use this like Ethereum? Say I want to make my own ERC20 or whatever. Why is Tritium a better idea? And what have you solved with this?
Do you know how to code?
No, I don't know how to do any of this.
So that's the first problem. And then the second problem is that there's one blockchain developer for every 14 projects. Right? And then the third problem is that you have a lot of error proneness when you have regular programmers that learn this new language and don't understand all the implications of what they're doing. Right? So when you said, how would I build one? The way we're designing it with the Nexus interface on our interface layer, that's a modular interface. So you'll be able to basically have a module for each different type of contract, and the idea is that you'll be able to drag and drop. You'll be able to create a token right there, or you'll be able to create a data register that would be your metadata or your copyrights or things like that, so that for the end user, it's a very simple experience. Now,
this is the easy button for Ethereum.
The easy button, yes. But there's still layers of abstraction. So for somebody that doesn't know how to code, they sit on the interface layer, right? Now, let's say you hire some developers that have proficiency in JavaScript and other things. They would be working on the logical layer. And so what they could do is they could actually customize and create modules for you on the interface layer. And through the logical layer, interact with the API and make more complex contracts for you, right? So they're not going to have to worry about all of the error-prone complexities of it because it's going to be somewhat automated when you make an API call. It's going to do all this stuff on the underlay, just like what happens when you open up a connection to a website. All this stuff on those lower layers is doing all these crazy things. And the deeper you get, the more things start to happen. I mean, down in layer 3 of the OSI stack, I mean, you get some really strange things. I mean, on the session layer, it's a little bit easier. But the lower down, the more technical and proficient you generally have to be. So we're doing it on that same level so that you can choose your point. So let's say you start and you build your interface and you're like, well, this drag and drop module doesn't do what I want. So I'm gonna hire a developer to make me a new interface module and a logical module that's going to be able to interact with the API. Well, now let's say this API doesn't give me everything I want. Well, then what you're gonna be able to do is you're gonna be able to go, you're gonna find coders, or you go to a Nexus conference and you get seated on a working group for that specific API and say, well, I needed to do this, my business needs that, and you talk with other businesses and they start standardizing more of the calls, which then goes down to the lower level engineers on the operation and register layer that then do all of the complex, I guess you could call it sequences of logic that enable that API call to function. So when you get down on those lower levels, you need standardization protocols, you need organization, because the internet is founded on that. There's something called the IETF, the Internet Engineering Task Force, and they're the guys down on the IP layer. They're the guys that created TCP/IP and standardized it. They standardized UDP. They made everything. Everything that crypto is built on was made by these engineers that sit in these working groups 3 times a year, and they put up a document and say, this is my proposal for a new protocol, and then it's called an RFC because that means request for comments. And they go and somebody else takes the mic, and sometimes they're vicious, sometimes they're helpful, and they attack it and they rip it apart. And you have some of the world's best programmers there. Most of these guys in the IETF are 40s or 50s, 60s, because they've been building the internet forever. And so they rip apart every idea until that idea becomes strong, and then that eventually moves to becoming an RFC and then an ISO. So that's what creates a standardization on the internet. So in the same way, it's going to be that way with Nexus. So the user is going to sit up on the logical and interface, or conventional developers will sit on the logical. And then the deeper down you get, the more sophisticated the programmer you are, so that people can do what they normally want to do. A conventional developer may just want to do an ERC20 token, or
and this is the whole modular idea that separates you from the bubble gum.
Yeah, and it keeps the guys that really know what they're doing down in the layers where it really means something to know what you're doing. You know, I mean, if you make a mistake with an API call and you get a bug on the logical layer, it's not a big deal. But if you program a smart contract, which basically a smart contract in Ethereum is the ledger layer coupled with the operation layer. So there's no register layer. It's actually stack-based between there.
You know, you're talking about Ethereum being this big ball of code. Having it modular like that, it's more insulated from attack than, say, Ethereum is, because Ethereum is constantly having hacks and attacks and this and that's going on with the DAO, and some dude putting up his private key so that people will come and steal his ether, and then they ended up getting ripped off. So, you know, so you're adding all these layers of insulation between that. So how safe is it? If I want to, what's the level of separation between Ethereum and Tritium as far as?
I'd say the level of safety is going to be a lot higher. I mean, I don't like to speak in absolutes. As it gets developed more and more, we're going to be able to determine that. But I mean, the focus is obviously to make it as safe as possible for the end user. So, I mean, if you start diving into the operation layers, right, and start changing that, that's going to require actual major consensus updates, which is going to require a lot of developers collaborating on that. So it's going to be fairly safe as long as you don't have really bad developers down there. It's going to be built very, very well, and then the user is going to have a very safe experience because they'll just get an error through the API instead of a security hole.
And Juan, so what's your take on, you know, kind of Ethereum and what he's talking about? Can you explain that for the layman?
Well, I have a question that might help illuminate that. So right now, the big sort of buzz is EOS, and everybody's talking about EOS, and EOS claims that they're decentralized. And the critique is that they have a very small amount of nodes in the network, and so there's kind of physically, like geopolitically centralized, right? There's going to be, maybe 50, right? Whereas with Ethereum, you have probably 10,000 nodes or 5,000 nodes, and they're doing on-chain scaling, and they can't, their blockchain, when there is actually stuff happening, gets overwhelmed. And the famous example is the CryptoKitties, right?
Yep.
Completely overwhelmed their network. Where are you in that spectrum? How do you guys deal with scalability plus? Well, we can, if we talk about that, then maybe enough people will kind of start getting a sense of it.
So the scalability comes down on layer 2 and layer 1. That's where you get your massive amounts of scalability. That's the ledger level and the network level. So what we're doing on the network level is we're using IP multicast and location identity separation protocol, which was developed by Dino Farinacci. And it's been in an IETF working group for, I think, over 10 years. There's a lot of people all over. What it basically means is I can have a single phone number as your internet address, just think of it as that, and then you have routing locators on the underlay that basically find you. So if we're here and I know your EID and I try to connect to it, we're gonna have a Wi-Fi peer-to-peer ad hoc network, and that'll be our loc for the moment. Or I go outside, then I have to go through LTE, or maybe I find a satellite, I can hit a satellite. So Lisp enables you to decouple the actual routing from your actual identification. So you don't really necessarily have to know where an EID is. It actually can still be private and obfuscated, but you can always know that you can connect to that person directly because they'll have a static IP.
This is related to IPv6, right? Like there's some
IPv6 is kind of, the relation is that most of the internet does not fully route IP version 6 right now. So you don't always get an IP6 route, and it's been that way since the 90s. So what Lisp allows you to do is, since you have your own address space and you can own your own address space, you can use IP6, or you can use new IP protocols, which is something that we're assessing as far as enabling partitioning in the database, where you can actually utilize the internet as your routing infrastructure between memory locations, and let's call it a register's memory address can be an EID. And then you can always access that memory address, and whatever nodes service that end up being able to be sorted by, let's say, TTL, which is time to live, which would tell you the number of routers that it passed through before you got to that, or round trip time, so you can always get your closest geographic data location. So that's one way we scale on the network. Another way is what's called IP multicast. So IP unicast would be, I talk to Danny over here, and I whisper a message in his ear, and then he goes and he whispers a message to his wife, and then whispers a message to Brian, and then Brian whispers a message to you, right? That's how messages travel through the internet, generally. It's unicast, and in a peer-to-peer network especially, the message has to travel through all the nodes before it gets there. Now with multicast, it's what I'm doing right now. I'm multicasting to everybody in this room. I'm giving one message and everybody gets it. Yeah. So the internet doesn't entirely support IP multicast because ISPs route each other's traffic, right? So since they route each other's traffic, they kind of have an unwritten law that I'll route for you, you route for me, but I mean, why am I gonna route your multicast traffic? You could give me 10,000 packets I have to replicate. That's not fair. So IP multicast never really saw full fruition, but what's really cool about Lisp is it actually, on the software layers, it on layer 3 instead of layer 2, right? IP multicast will be replicated on the router layer, but Lisp on layer 3 can actually do the replication as head-end forwarding, so it can mimic IP multicast if the router doesn't support it. So we can create these IP multicast links, right? And then everybody on the network receives the message at the same time.
Yeah, that's a big deal. Being supported by the
huge deal. Right now, blockchains are flood networks, right? So to not get too technical, it's called exponential time. So it's n squared. So the total number of nodes squared is the routing complexity. So that means the more nodes you add, you exponentially draw more resources from the network. And a lot of people just sit and they open TCP IP connections and they're like, it works, great. But when you start learning about these lower levels of even the OSI reference stack, you start seeing everything that goes into it, and we just assume that the internet works. We just assume I can go to this website. And we don't realize all these layers of abstraction that are making that possible. So when you really want to start talking about globally scalable systems, you have to look at scaling on the network layers, because the scaling of the network is what allows blockchains to even function to propagate messages. That's how the internet functions, because the network was able to design scalable solutions. So that's our first layer, right? IP multicast and Lisp are two big things. Now, then the next layer is the ledger. Right? So a blockchain, as we know it, is a linear data structure. And every block is chained, there's no parallel processing, and I have to basically validate this block before it routes to everybody, right? So for one, let's just say we're using a conventional blockchain for the ledger level. If you have IP multicast, everybody's not going to need to validate that to pass on to everybody. Everybody will be able to subscribe to the multicast link and then validate the blocks independently. So blocks will propagate much faster, right? But you still get the complexity, and we were discussing a little earlier about, well, if you have 100 megabyte, 100 gigabyte blocks, I mean, it could take 5-10 minutes to validate that block. Ethereum already takes 25 seconds to validate a block if you do not have a solid state drive. So the block time is 15 minutes or 15 seconds, which means that you have to have an SSD to run Ethereum, right? So they're already reaching this upper limit of complexity, even though they don't have a block size, because it's the hard drive that is becoming a bottleneck because they have to do reads and writes. So if you have to have this, I call it like a big chunk of data, like a freight ship. If a freight ship just came into the middle of every city and then just threw the mail, and then you have to go find out like where your letter is in this giant freight ship, it's not going to be scalable, right? The mail system works because you have a freight ship that goes to a port. The port delivers it to the big trucks. The trucks drive it to their local locations, and then from their local locations, they go into the individual mail truck and they deliver it to the person, right? That's the type of idea of aggregation, where you go from huge to small and you hone in. And that's kind of where we're designing with the ledger, called the three-dimensional chain. I know people have heard about it, we've spoken about it for a while, but what's cool about the Tritium white paper is we can show people the significance and also what part the 3D chain fits in the software stack, the Nexus software stack.
That distribution of, that the way that you just described the delivery of mail, that's how trees work.
That's how nature works.
Nature has.
That's how the internet works.
So.
Yeah, exactly. And so, I mean, why don't we trust natural process? I mean, that's how everything functions. It starts big and then it breaks up into more and more specialized pieces. So that type of idea is what we're doing with the crypto to create the 3D chain. And it's, I guess you could call it data aggregation, but I also say it's checking and balancing. Right now, Bitcoin is validated completely by the miners, and the miners choose what transactions they want in the block. So even if you have omni-layer protocols like Counterparty that are riding on Bitcoin, the miners can decide to censor that and not include that in blocks, and you could end up waiting a long time because there's no rule to stipulate that you have to include transactions in a block.
Yeah, they're assuming competition, right? Like if it gets centralized, it could censor, right? And that's
it really just depends on the self-interest of the individual, and that's something that you constantly have to design these systems to, I guess, drive self-interest into collective interest, where collectively miners fulfilling their self-interest to mine blocks and earn money provide as a procession to the rest of the network, kind of like how a bee is just seeking to find nectar to create honey, and it happens to pollinate flowers.
So so you're trying to add ease of use for the user for these smart contracts, more capacity, so there's more transactions available per second, and what about cost? How does that?
I'd like to say that transactions can be made free with the signature chain algorithms. So signature chains are a part of the ledger, but what it allows us to do is prevent you from creating dust spam attacks because we don't have the UTXO model. And then it automatically you could call it, the next hash becomes almost like an N1, so you can only claim one next hash at one time, and then you can lock that to a certain number of iterations, or you can make one transaction per minute, or you can throttle someone's transactions. You have all sorts of things when you have a connection of a specific user, right? So with the cost of using it, I'd say that paying for a register space would be warranted. You pay for a certain number of bytes, which would be a register, which is kind of how CPUs work. You have your L3 cache because you're reading and writing from registers and then storing computed values in those registers, and then you're pulling those out of the registers and storing it in memory, right? So the same type of thing in creating a truly distributed computer is the same thing with these registers.
You're prepaying for a bundle of transactions.
Well, not even just that. You're buying a space on this distributed computer, and you're contributing some Nexus tokens for it. So from this space, you can do whatever you want. That register could record checksums. That could be for omni-layer protocols. That could be checksums of your databases. That could be authorizations for different people. Or it could even be recording a state in the ledger of a logical layer program you have, so that if this logical layer program fails or the whole system goes down, you can always read your state and start back up. And you have fault tolerance in that respect.
In the crypto space, we have a series of concepts that are kind of familiar to people. So nodes and node counts, and then you have tiers of nodes, right? So Dash is a popular one where you have multi-tier nodes, right? And NEM uses a similar system. So that's one of the ways that we look at these things. And then you have the proof of work or the mine algorithm, and there's merged mine sort of systems already, proof of stake, proof of work. Can you tell us a little bit, lay out the sort of topology of the network? Like, are all nodes equal, for example? Is there sort of, you obviously pay using inflation to reward proof of work and proof of stake. So you kind of have a proof of stake layer, and we'll talk more about that, right?
Yeah, so, I mean, I guess to say how it exists right now, yes, we have proof of work, proof of stake, and then, two proof of work. So we have prime and hash, and then proof of stake, which is Nexus proof of stake. So the proof of stake channel is, you get a variable interest rate based upon your time contribution to the network. So that's the first step towards building a trust system, where you build a distributed trust system because, as you know, I'm sure you've heard of Byzantine fault tolerance. Ethereum talked a lot about that, and that states about the two generals problem, where if you have two generals and you need a coordinated attack and they can't necessarily communicate, how do you exactly determine that the message is valid if either of them could be malicious? And what my common bottom line of that is mathematics. 1 + 1 is 2, 1 + 1 is 2. I can verify that, you can verify that. We know that it's a valid message. That's what Bitcoin uses. It uses the hash as the mathematical proof that a certain amount of work was done, and then that becomes what's trusted. So we're developing kind of something that I call that a momentary weight, but the trust system is weight over time, right? Your contribution over time. So that develops, I guess you could consider that part of a tier, but I don't really like to consider Nexus tiered, because there's not anything that you have to buy into or get access to with a delegated proof of stake model like NEM uses or EOS uses. You have to be delegated by the stakeholders, right? So that creates the tier 2. With Dash and Master nodes, you have to purchase one of them, which I don't know the cost of a Master node now, a few $1 million.
273,000.
273,000.
Yeah.
So yeah, I mean, now some people can do that, and that does create trust because it creates a cost to attack it. But then again, there's people in Indonesia that don't have 2 pennies to rub together. So how do we balance this security with availability for any user? So that's where the trust system, at least what we're designing it to be, is supposed to do, where anybody can come in and actually build their trust up in the network. And that trust is rewarded with, or the more trust, is rewarded with higher rewards, so that people can come in and they spend their time, and then by spending their time, they actually are able to build themselves up in the network. So instead of it being multi-tiered, I'd say almost like these cans, it would be horizontal, but checked and balanced. So the proof of stake and the 2 proof of work channels, they all check and balance one another. There is not one above the other. But if one starts to get a little out of control, then the other ones can bring them back down. So that kind of enables a system, just as the United States was designed, to have checks and balances in government, checks and balances in power. Validators are the power of the network. So they need to have checks and balances.
Designed and intended.
Yeah.
But,
It didn't work too well, but we learned from it, and we move forward, and we figured out what works and what doesn't.
Yeah, and even now, with crypto, when you...
It's another check and balance.
It's happening now with a lot of different platforms. Bitcoin and Blockstream and their relation, and Roger Ver and Bitcoin Cash and all that. Checks and balances can get out of balance.
And it seems that those two extremes have kind of potentially gotten out of balance. I mean, I don't want to speak negatively about any figures, but I mean, when opposites are carried to the extreme, they're alike. I always say in absolute light, you're just as blind as absolute dark. So it's about finding the middle ground that allows visibility, and I think maybe both sides are on this polarity, competition. And maybe if we just met in the middle and kind of found that middle ground, that would be best for everybody instead of just best for one side.
Yeah, there's a lot of experimentation to try to find the optimal image.
Are there any features that you think Tritium will have that the others don't have? I mean, things that you can do with Tritium that you can't do with Ethereum or EOS or any of the others?
I think there's going to be, I'll say it honestly, I'm not entirely sure of every use case that's ever going to be made. I know what we need to build, and we spend a great deal of time here at Nexus talking to people and asking them what they need. And we found a lot of areas, like I haven't really seen Ethereum or EOS be able to tackle the copyright issue or the voting issue because they don't have identity, right? Or at least some sort of cryptographic identity. It doesn't necessarily have to be, hi, I'm Colin right here. This is my address. But a pseudo-anonymity. But just, what I mean by identity is a series of events that lead you to be you. Now, if you have, let's say, a voting system, let's say here in Phoenix, the Phoenix government is obviously going to want to make sure things are vetted. So like DocuSign does, they go and they vet somebody, and they have the liability of vetting that. So when you have signature chains and identities, they can publish that they are them, and they can publish a signature on their website saying they are them, and you can verify anybody to say that their sig chain is their sig chain, and then they can sign off on individual people to state that you are a resident of Phoenix or things like that. And then you can develop that type of reputation, and then you need that if you want to do copyrights. Because how do I know who you are or what you are? Well, you know that I own this metadata for this copyright, and here's my licensing contract, and now I can transfer money into that, and that can be dispersed. Now, I know the ERC standard is changing to certain levels. I'm not necessarily sure that they have gotten to those things, but we're looking at the practical, pragmatic uses for it. So theoretically, with Ethereum being Turing complete, you can build anything, but then on the other caveat, it's not scalable enough to handle such complexities, and the prone to error that you get generally causes, lack of ability to adopt that. So I believe that we do have a very great formula, especially with this white paper, to be able to create these practical use cases that smart contracts promise. From my perspective anyway, all I've seen smart contracts really do is CryptoKitties and ERC20 tokens.
Yeah, that's about it. It's raised a bunch of ICOs. That's pretty much it. What about embassies? What role do embassies play, especially like in governance?
Well, so just one of my observations over, I've been in crypto since 2013, is that there's generally entities that act as stewards for the protocol development, right? First it was the Bitcoin Foundation, and then Blockstream eventually kind of became the predominant one, and the Bitcoin Foundation kind of disappeared. You have the Litecoin Foundation, you have Dash, I'm not sure if they're Dash Inc. or...
Dash Core Group, but
Dash
it's not.
Group.
They're not really in charge of Dash. It's the masternodes that are actually in charge.
Well, from what I understand, the masternode votes just are a vote, but it's Evan that holds the keys to the treasury, correct? Or am I wrong on that?
I don't think so. I know, he stated actually here in Phoenix that he turned off all of his masternodes. So that he's not.
That's a good thing.
He's not voting. He stepped away from that. I don't know. I guess he still owns the coins, and he made a statement of how many coins he had. I think it was like 250,000 or something like that. I'm not sure.
How do they disperse the coins from the treasury?
How do they? That's automatic. Dash Central sends that out every month when after all the masternodes vote on the proposals, then the coins are sent out automatically.
You mean like on the budget reward system?
Yeah.
Yeah, that comes out of the block reward.
It comes out of, 10%.
Cool.
10% of the entire block reward goes to funding this. So you have 45% is your proof of work mining. Mm-hmm. The other 45% are the masternodes that do a lot of these functions, and then the 10% is set aside for development, advertising, and things like that.
That 10% dispersed based on messages and proofs of masternode votes, or does it disperse?
Yeah.
Okay.
Yeah.
Cool. So they're a lot more advanced than I heard. That's good. Yeah. So that's a similar type of model that we're kind of looking at, but instead of it being masternode based or multi-tier based, what we're looking at is having nonprofits be around the world, being in each different country, and then being able to democratically be voted in and out, and have a funding based upon what they would need to do. Hey, I need to hire.
Is there a percentage of your block reward that's set aside for that? How is that?
There's a percentage
how's that
right now?
Okay. What's your ratio on
It's
that?
about 15-20%.
15 or 20%.
Yeah.
Oh, that's pretty good.
Yeah. In regards to voting, identity is obviously a very important question.
Mm-hmm.
Can you explain a little bit about how you guys are finding identity from digital to the analog, right? There's a bunch of different solutions that you can do digital identity in. It goes from KYC to pseudonymity with cryptographic signatures to maybe like data analysis, right? Or just anonymity, etc. How do you identify a player? How do you verify the authenticity of a vote?
So that really is not something that we do. Okay. As far as the actual DAC, because that's what we're developing is the distributed autonomous community. That's the global. So the way you verify the identity of a vote is based on the threshold of your trust, based on how much resource you've contributed to the network and your track record. So that's how you weight the vote, at least on one level, because there's 6 voting groups. So in order to prevent a mob rules type scenario, and also to have resource input in different type of perspectives, I guess you could say, is developers are going to have a perspective, ambassadors will have a perspective. Just regular token holders will have perspectives. Each type of validator will have different perspectives. So that's where you get the 6 voting groups. So the total number of tokens will be 1, right, based on your token vote. The total number of actual L1 validators trust will be the next vote, which L1 on a 3DC will be the people that are doing the first level of validation.
Sorry, what was the first one? 1 token. You just start again.
Okay, so first one was we have token, so the currency holders.
So that one was stake based. 1 token, 1 vote.
1 token, 1 vote, or basically, yeah, when you get the total coin supply or 51% of it, let's say, then that becomes a +1 vote for that group, right? And then all of the trust of the L1 validators is a 1 vote. And then all of the trust of the L2 validators is a 1 vote. Then all of the trust of the L3 validators is 1 vote. And then all of the trust, or all of the ambassadors or the embassies is 1 vote. And then all of the developers is 1 vote. So that way you can create kind of a distributed governance structure, but nobody is tied to anything. So an ambassador has to perform to develop the foundations of meritocracy. If an embassy doesn't perform well, or the community is not happy with what they're doing, or they think that things need to be changed, they can issue a vote just the same to remove them. And what that's going to do is that's going to cut their funding directly out. So the same thing with the developers. It's going to be developers hired in by the network, and they can be fired just as quickly.
What about this notion of twin blocks? What is a twin block, and how does that apply?
So basically, if you have 2 blocks that happen to be mined at the same height, right? Since we have 3 different channels, each one operates on their own reserve or reward ratio. So if you get 2 blocks that are actually at the same height and they have no lock conflicts, they can actually reinforce each other and create a form of horizontal scaling where you have double the capacity of the block size for that moment. And then that links forward to the next one. So what that does is that creates a better checking and balancing system, and it reduces orphan rates. And it also doesn't inflate supply beyond the actual mathematical designs.
Right. Okay. So that's really more something that we would cover in the actual Nexus blockchain when we kind of go over the diagramming and everything.
Yeah, that would be a part, and that's one of the features to the ledger level on Tritium. So the Tritium white paper is broken out. It shows the software stack, and then each section is each aspect of the stack that's going to be built. Right. Now, there's also a mean and Obsidian, which are the next updates from Tritium. So that's called the Tau framework, and through each one of these, there's going to be improvements on each one of these 7 aspects of the stack. So that's just a Tritium-specific ledger feature that we're going to be implementing.
Everybody projects dates about things. What's a realistic date for Tritium actually being usable? Because hey, we're going to do it this fall. It's next fall. What do you think? What do you think is a realistic date for this actually being usable?
Generally, this is a more complex question, because the whole entirety of Tritium is going to be unlocked through each layer, and pieces will be put in each new update. So we're going to be seeing...
so the Nexus coin itself will just be receiving these updates until Tritium is active? Or?
Till the full set of all of the features are active.
Okay.
So the first stage that we're really looking at is the Tritium interface, which Brian over there has been working with the team on, and that's coming together very beautifully. Yeah. And then some of the ledger level code, which is going to be signature chains. So that's going to be another big one. And then state registers. So you're going to be able to record certain data in, and you'll have an identity marked with that, and then you're going to have a better trust system. And so those are some of the basis of the Tritium base, but then we're going to be unlocking more. So with this next Nexus conference, we're hoping that we get more input from businesses, people in the industry, in order to define the API calls a little bit better and have some of the first working groups and see how they start to come together. As you remember the last Nexus conference, we had similar type of vibe. They were less working groups and they were more dreaming groups. But now that we can hit the ground running, we can start to decide these things. So we're looking for different leaders in different industries to come together and help start standardizing that. And that's one of the reasons that we're also choosing to methodically roll Tritium out. Instead of putting it out and saying this is everything you're ever going to need, we let people that are going to use it help develop it. And what that means is help contribute to the direction of the development, so that we can have a more community developer.
It's probably much safer that way, to break the small things in each step, so that your foundation is kind of built
very strong,
a lot more solid by the time you reach the end of what your protocol is going to be.
And the foundation work is the most important work. And I mean, Nexus has been around since 2014, and we're still doing foundation work.
Tritium is your next big stage. It's sort of like like with Ethereum, they used to talk about frontier, and is that kind of how you guys think?
I wouldn't consider it like the Ethereum updates. I mean, the Ethereum updates are pretty consistent. I wouldn't say that there's huge feature rollouts on them. I mean, they change some op codes, or they make it more stable, or make some GUIs. I mean, each one of these are major changes. So the Tritium one is incorporating the ledger changes and then building that stack up, right? And then Amin is actually getting some of the 3DC activated with the L1, L2 locks, and then still conventional miner validation. And then Obsidian is going to be the L3 locks, which is going to kind of make the network act like a distributed mining pool. And that's also going to unlock the distributed autonomous community, because with the linear blockchain, having a network-wide vote that grows so large, with having the public in all these voting groups, there's going to need to be a large data handling. So Obsidian is going to be that next step that's going to also handle a lot of also our database things, but I'll go into a little bit of that later. That's kind of something I'm keeping under wraps on how we're going to shard. And it's not a conventional way to shard. It's actually a really, really interesting thing we actually just discovered about a month ago with Dino. So that's going to be really, really fun. But we're rolling it out in these 3 stages too, because every Nexus conference, there's going to be more and more input and more people. And I've seen a disconnect between developers and community in crypto and a lot of cryptocurrencies. And the developers have this we know all complex, and they develop everything and think that that's what everybody needs. But we kind of go and we talk to people and say, what do you need, and how can we help, and what are your ideas, and here's what a distributed ledger can do. How can we provide this for you? How can we help you integrate and based on their feedback, that's part of what brought us to writing the Tritium white paper, and that's how we define this architecture, by understanding these things. So as Amin and Obsidian are unlocked, all of the standardizations from the previous year will be implemented, and they'll be worked on for that year and designed and developed and then deployed, and so on and so forth. So we're expecting to have Obsidian later 2020 is what our hope is, depending on how quickly we scale up the development team.
Do you have any visions of maybe building social networks on top of this, YouTube alternatives? And
yeah, there's going to be a lot of possibilities, but this is where you said the foundation is the most important part.
And then one of the things that we actually talked about the other day, and you said you had some ideas. What do you think about that as far as GitHub?
Yeah, well, that one's a little further. But the idea is that, so we got developers, right? Now the developer group, let's fast forward to Obsidian, right? We've got the 3DC, we've got advanced contracts working on the Tritium software stack. Everything functions. You've got developers that are either voted in or out. So what if developers are the ones that change constants on the protocol? So let's say, just for lack of it, there's not going to be a block size, but let's say, just for an example, there's a block size in 2020. And this block size is encoded in a state register that's signed on a multi-sig contract by all the developers, that then becomes valid rules based on the developers, which means the network can live hard fork based on a transaction signed by everybody. So on that sense, that's one way you do full consensus updates. And then the next one is when you have state registers too that are owned by this multi-sig contract. Commits can be put into a state register. And so the code can actually be pulled through all the indexes on that developer sig chain that can then basically be emulating from Git, and then the API would probably be handling the Git requests or anything like that, so that you can pull the code from the code, right? So having that ledger and writing anything in that ledger, you'll be able to build the code and store the code in the ledger itself, which I think is the most, lack of better words, optimistic, or that's the mark we need to meet. Now the complexities to get there, that's going to be part of the engineering challenge, but that's the idea, is if we're building these systems to be hundreds of years old.
Microsoft.
Yeah, exactly. I mean, GitHub's a big centralization fail point. I mean, if you look at it, development is a big place that centralization happens, and mining is another place that centralization happens. So with Bitcoin Core is called Bitcoin Core because it's called Bitcoin Core on GitHub. Yeah. And it's the Bitcoin organization. And that's owned by the Blockstream guys or some of the main guys. And so that's where we get, we can debate. There's other people in there. Yes. I'm not going to speak in any conspiracies. Like I like to try to keep as neutral as possible in all of this, because we're kind of doing our own thing over here, and crypto can do whatever it wants to over here. But I mean, ultimately, people determine Bitcoin as the code that's on GitHub.
Yeah, and I really like that you're identifying the different values that certain groups of individuals have within this communities, because that is a big reason why we're seeing the conflicts that we see in the crypto space these days, is people with different immediate priorities fighting about the future of the thing.
And they're all right.
And they're all right in their own, within their own priorities.
From their own perspective, they're all right.
Yeah.
So how do we help that perspective? Because right now it's developers and miners that upgrade the protocol. But exchanges, they put petitions out to upgrade the block size, and developers had certain reason to say no, and exchanges had other reasons to say yes, and miners had certain reasons to say no, and then other miners had reasons to say yes. And that lack of consensus is what's created, I think, a split in the community where we have Bitcoin Cash and we have Bitcoin. And both are arguing about what's the valid Bitcoin. And I think that wouldn't have happened if we had better governance structure like what Dash has. I mean, it's good to hear that they validate on chain all of the masternode votes, because that makes me feel that's the proper way to do it. And that's the way it all needs to be validated on a ledger, because the ledger is your truth box. And that's how everybody can reference that and say this is the truth. So when it comes to code, that can be the same thing. And then when a developer is not appointed by another developer, right, which I'm not going to call the developers falling into nepotism, but I mean, it's kind of how board of directors work. The board appoints a new board member, and that generally creates nepotism, or it creates your closed circle becomes the people that control the circle. But when it's the public that gets to appoint those people, I think it changes the game quite significantly. And I'd be very curious to see what the general consensus of the entire Bitcoin community was on everything that's happening, on what the people would want, as well as what the developers would want, as well as what the exchanges would want, as well as what the miners would want. I mean, because they're all valid parts. I mean, without the community, Bitcoin wouldn't be anything. Miners would just be mining a bunch of random hashes.
Certainly would be great to have higher quality information about what the actual consensus decisions are, because a lot of it happened on Twitter. A lot of it, you had to be like near level journalist to, like I used to be a journalist in this space, so I know where the sources are. I can go and start looking at primary sources and not second party, third party, and there's a lot of different dynamics, right? So if you can,
I think that's going to be a key part moving forward. And the projects that start moving towards DAOs and DACs, I think are going to be the ones that become more of the future, because I believe companies are going to eventually become more like DAOs. And then the reason I say DAO, and
you need like advertising and things like that for growth. I mean, if people don't know about you, who's going to use you?
Well, and if people don't develop the protocol, then when bad things happen, nobody can fix it.
Well, speaking of bad things, when I walked in today, you guys were tackling some hacker that was trying to attack your code. Obviously, that's something that happens all the time. So you have a whole office full of people here to handle that.
And people all over the world too.
Yeah. And so walk us through what that's like. I mean, because I'm sure there's so many coins out here. You like Verge, and everybody's getting 51% attacked. You guys have not really had any attacks like that.
No,
why is that?
We haven't had a 51% attack ever, because we have the three channels. So I mean, even if somebody did try to
33%.
Well, I mean, they'd have to 51% two of the channels. So it'd be like a 77 or 70% depending. But the thing is, also there's other protocol things that we put in, such as soft banning. So soft banning is a really unique feature where you don't necessarily create a hard break on the blockchain where you say this block is invalid because it violated these rules. What you do is you detect malicious activity, and this is the beginning of kind of how an immune system works in the body. It identifies an RNA sequence, which is a virus, and it can identify, since it can measure itself, the body, it can know what it's not, and then it can identify that virus and eliminate it. So in the same way, the network is, I mean, not to the full machine learning, but it's developing these different types of awarenesses of malicious activity on the network. So if you see a GPU channel try to create too many blocks in a row with a timestamp less than 20 seconds from a similar key, you're going to see that that's something slightly malicious. And then what you do is nodes just choose, hey, well, if you're acting a little bit out of whack here, I'm just going to ignore you. And they don't relay their block. So in order for that block to become valid, another miner will have to build on that, which means a miner has to get it. And so the more and more that the network can start learning, and this is where you get the relationship system that we talked about in the Tritium white paper, where I always state it as, when the network can know itself, then the network can know what it's not. And when the network can know what it's not, it can isolate an attack and get rid of it. So you have the ledger level trust, right, on Tritium, but there's going to be an actual network layer trust, where you're essentially going to build a relationship with other nodes, and you can get a data set, let's say, of the last 5 months worth of talking to these nodes. And I can basically take that in and I can average it out and I can find out a common line, right? A common sequence of events that's normal. And then when you see spikes, you know that that's abnormal behavior. And from that abnormal behavior, you can detect that and just ignore it. And then what happens is attacks have less ability to propagate through the network. So that's one thing that we've developed. There's, a lot of things, just because we've been around since 2014 and we've made a lot of innovations. And so there's a lot of people that they've tried to attack. And we've said, this is, using 1024-bit hashing. So we're a lot more secure. And people will be like, oh, you want to find out? And they'll try it. And it happened on the first day. So part of it's the battle hardening. Mm-hmm. And being under constant attack and then being able to isolate the attacks, find the attacks, resolve the attacks. And then other parts of it is just being surrounded by really great developers with a lot of very creative minds and being able to think in that out-of-box abstract way to say, well, we can develop security in more ways than just hashing power. We can develop an intelligence on the protocol so that it can know what's good and what's bad. And then from that, it can learn, well, if I made a bad decision that was actually good, then I'm going to change the way I see good and bad. And so that way, over time, nodes that build this relationship with one another, if an attacker comes in, they're going to instantly be notified or seen as outsiders because they're not known. All these nodes just join the system. Okay, well, we need to talk to you first before we trust you or get to know you. And then these nodes start talking and be like, okay, these guys are cool. And then maybe you talk for 2 months and then they go, rah, and they try to attack. Well, you've been talking to your other guys for a year and you know what normally you talk about, and you see these guys, well, yeah, you came in and then you just tried to talk to us for 2 months to try to build up our trust and then tried to attack us. And so in a similar way how humans have relationships, right? You build a relationship with somebody personally and privately, that's a relationship system. And then reputation or trust is your public reputation of the publicly visible series of events that you have done that other people can use to reference your validity of, reputability or trustworthiness in the network.
What are some of the actions that nodes will play in order to gain trust, just to get a sense of that?
One of them will be validation, obviously. So if you're acting as an L1 and an L2 validator, that's going to be kind of how you build reputation, right? So we need to decouple reputation and relationships so you can see the difference. So reputation is going to basically be just, well, I've seen you've validated this many times for 1 month, and then he stopped for 2 months, and then he came back for 2 weeks, and then, you'll be able to see what they've done to contribute to the network. So reputation is based on meritocracy, your contribution to the validation state of the network. Relationship would be, we're normally talking, and hey, since you have an EID and I have an EID, then I now have a reputation tied on the network layer, right? That's very powerful. So I can know that when I'm always talking to your SIG chain, I'm talking to your only endpoint, so I can see.
McAfee actually had something like that, where he was talking that whole same thing. That just reminded me of something he was talking about. But one of the things that you said about Ethereum is it's like one of the chinks in its armor is that it's overcomplicated. Your blockchain is pretty complicated. How do you find the balance to?
So the stack is one, and then the engineering working groups is the other, and then the working groups for businesses is the last. So, you don't start with a huge generic template, right? ASICs are faster than normal GPUs or CPUs because they're specialized. So we design certain things to be specialized for certain processes that are needed so that you don't create needless complexity more than what people require for functionality. And you get the requirement for functionality by distributed consensus.
And also, speaking of the complexities of your blockchain, do you want to get into explaining how that works? And we can do a diagram, or do you have anything else before that?
Question that you mentioned earlier that one of the parts of your vision is to kind of lay down a map for how blockchains can upgrade to what you guys are building. Do you want to talk a little bit about that?
I started basically building Nexus in 2014 with the pure coin source code. I wanted to start with something that was battle hardened, tested, and I made heavy modifications to it. You can read in the Genesis white paper the descriptions of all of those, including multiple channels, SK1024, SK512 across the board for hashes, 571-bit keys. We can go on and on and on. But no, we don't have any existing pure coin code as far as the proof of stake built the whole proof of stake system from scratch because the Purecoin one just was not up to at least my standard for code. So there's very, very, very few pieces of that code left in the code right now. But it taught us a lot to bring us to where we are now. So in a similar perspective, with that being said and known, Tritium and Obsidian are going to transfer this blockchain from its heavy modifications now into a three-dimensional ledger with the software stack. And the idea is that as we're going to be upgrading this live network, other people will be able to inherit that as well, as long as they have the prerequisites upgraded into their blockchain. Pre-Tritium, right? Like you need some certain aspects of signature chains, possibly that's a Tritium feature. You need maybe the reserves, the multiple mining channels, a few things but we'll define that. Unified time you definitely will need. That if Verge had unified time, they wouldn't have had this attack happen. Our clocks are within 1 second of one another. They cannot sway from that. Now, the clock is not always the exact time, right? But it's the exact time on every computer. So right now it drifts because all of them, but the idea is that they all drift together. And as long as there's no difference in the time, you can't create attack vectors. If there's a difference where you see 100 seconds ahead of me, then I have 100 seconds to mess with your consensus, right? So anyway, the prerequisites in place. Yes, Tritium, and Obsidian will be able to transfer or transition a linear blockchain into a full three-dimensional chain in hopes that other people find value in what we're doing. We're the ones paving out there into the unknown and building it and engineering it and upgrading it and doing all that work and testing it. And then just like what was passed to me when I started, we'll pass to other people and give them battle-hardened three-dimensional chains and software stacks that they can then build upon and abstract and grow. And I think that's going to really help the industry flourish because we're not about competing with any currency. We're about cooperating. We believe that cooperation is the future. I think that's how society is going to eventually move. I think we've reached our upper limits of competitive advantage, being productive for society. It does breed innovation to an extent, but it also stunts innovation when people steal from one another or they change certain little things about something to make it just another product to sell. And Metcalfe's law states that the value of a telecommunication system is based on the square of its participants. So 4 competing against 4, Bitcoin and Bitcoin Cash is 16 versus 16. It's an equal battle. But all of them together is 64, 8 squared. So mathematically it works out. So in hopes of demonstrating this and developing with the intentions and the principles, other people might find value in that too and utilize the technology as well.
Awesome. Well, I think it's a great aim to have as the vision to your project. Crazy question. Do you see in the future, let's say past the point where you have the 3D blockchain, do you see coins that have different proof of work, proof of stake, could they possibly merge? Just crazy question.
Yeah, I think they could merge, but see, there's the thing is, we got to look at it in this one perspective. Multiple blockchains has been a scaling solution, right? We can just fork Ethereum and make our own blockchain, right? CryptoKitties, I think, said that. But the problem is, every time you break off from the main, you reduce the total number of validators, which reduces the security. That's the problem with sidechains, right? So to that concept, yes, people merging together, projects merging together, I think is healthy. And I also think multiple 3DCs, maybe having interoperability, would be healthy as well. I'm not to say that there needs to be one, or there needs to be none, or everybody needs to merge together, or everybody needs to compete, but I think there's going to be a common ground that's going to be found, and I think there's going to have to be a certain number of people that aggregate together in order to make these networks strong, because that's really where the strength of a blockchain comes from, is the people using it, and the people mining it, and the people validating it. Otherwise, I could just use my CPU and 51% attack Bitcoin with their source code they have right now on my own testnet, because nobody else is there mining with me. So, you need more and more people to come together, yes, I believe. And so the long answer to that question is yes, I believe that's going to be possible, but I don't think it needs to be just one. I think there's a lot of room for a lot of different types that are going to be, tailored to specific uses in the world, I guess you could say.
There's more than just cash. There's all kinds of financial products all over the world, right? Whether they're scams or not is, that's a thing. But financial technologies and products and assets are, you can't get rid of.
Yep. Awesome. Yeah. Thank you. Good questions.
All right.
Thank you.
Yeah.
Okay, let's dive
Just met you
into
today
the-
too.
Yeah.
Yeah, let's dive into the
Dive into
what a
diagrams.
3-day blockchain is.
All right.